Hello and welcome to Nikolai's genetics lessons, but today's lesson is going to be about mathematics because mathematics is playing a major role in modern biology, computational biology, and genetics. So sometimes I also publish mathematical uh, problems, solutions, and today's lesson is going to be fun, believe me. So, what is the sum of 1 to 100? And basically, we are talking here about uh, finding sum of progression. And in our case, progression would be from 1 to 100. For example, basically we are asked to find the number uh, which is going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on up to 100. And there is an anecdote that small Gauss, this is famous European or German mathematician who was at that time 10 years old. His teacher, trying to punish him for misbehavior, asked him to add numbers from 1 to 100, and to his astonishment, the Gauss did it in just few minutes. So this is how sum of progression have been found, but nobody knows if it is true or not, or it's just an anecdote. But actually, take a look. Here is a picture of the Friedrich Gauss on the banknote uh, of 10 Deutschmarks. It is discontinued, of course, because now in European Union there is euro, but you can say that this mathematician have been honored by his country for his contribution to math. So basically, how we can solve this problem within minutes, and what 10 years old Friedrich Gauss proposed, and this is actually what he did. He considered that he can add all these numbers in pairs. For example, he can make two columns. In one column, all numbers would grow. For example, 1, 2, 3, 4, and 5. And in other column, they would decrease in numbers. So 100, 99, 98, and 97, 96, and so on. And if we add numbers in each pair, you would notice that we are going to get always 101. So 101 here, 101 here, and 101 here, and 101 here. So we can continue, but the picture is going to be the same. If we have numbers from 1 to 100, then we are going to have 50 such pairs. And that means that we also have to multiply 101 by 50. So we are going to get 50 pairs, and the answer is 5050. So now you see how easy to solve this problem, but there are also formula which makes it even easier than this. Take a look. For example, we may have another sequence. It's not necessary that sequence have to be like 1, 2, 3. And the sequence can be, for example, 2 and 5, 8, 11, and 14. But what is important that numbers in such a sequence have to be the difference between them have to be constant. Like, for example, between 2 and 5, the difference is 3. Between 5 and 8, the difference is 3. And the difference between 8 and 11, 3, and between 11 and 14 is also 3. In mathematics, an arithmetic progression or arithmetic sequence is a sequence of numbers such that the difference between the consecutive terms is constant. So again, we can now use a formula, and here is a formula. It is very simple, where sum of certain numbers would equal to n, and in parentheses we have a1 plus an and divided by 2. So let me explain here. So n here is a number of numbers. So we have here 1, 2, 3, 4, 5 numbers. So sum of this progression would equal to 5, and a1 is the first number. So we would have 2, and an would be the last number in the sequence. For example, here it is 14, so 2 plus 14 and divided by 2. So what we are going to get? We are going to get 5 multiplied by 16, which is going to be 80, divided by 2 would equal to 40. Let's check. For example, 2 plus 5 is 7, plus 8 is 15, plus 11 is 26, plus 14 is 40. And this is what we got using this formula. So as you see, it is very easy to solve, and this is a fun actually to do such math. It is not that difficult, as you see, to do calculations, even if we have large number of numbers which we have to add. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. See you in the next video. Goodbye.